So, chapter 2.6, example 20. The diagram shows a sketch of the graph y equals f of x. The curve passes through the origin, the point A, which is 2, -1, and the point B, which is 6, 4. Sketch the graphs of, in each case, find the coordinates of the images of the points O, A, and B. So, I like to do these by building them up using small sketches before I do the final thing. So if I think of f of x, what do I do to get to 2 lots of f of x? Well, that's a stretch, scale factor 2, and because the 2 is outside of the function f of x, it's outside the f, it's not inside the bracket with the x, it's got to move the points in the y direction. So the x-axis is invariant. So that means the graph, as far as my sketch is concerned, stays the same shape, but my y coordinates have doubled. So this will be 2, -2, and this will be at 6, 8. Yeah, these aren't my answers, remember, I'm just sort of building up the ideas. So now we've got to subtract 1. So 2 f of x, subtract the 1. Again, the 1 is outside, so the points are going to move in the y direction. So this transformation is a translation. And it's not moving it sideways because the change isn't inside the bracket and next to the x, it's outside the function f of x, and we're going to move it down 1. So now I'm in a position to draw out my answer. So here we go. Our shape is basically the same, and my y-intercept is negative, so it's somewhere down here. So there's 0. My y-intercept has moved down 1. This lowest point is still at 2, but it's moved down 1 more to -3. This is still at 6, but the y value's moved down 1 to become 7. I hope that's clear, and then we could label that y equals 2 lots of f of x, take away 1, and that's the, x-axis, and that's the y-axis. Okay, so we still need to keep going. Now, I was thinking I'd finish, but we've got 3 more to do. So part B, we've got f of x plus 2, so we want y equals f of x plus 2 plus 2. So we start next to the x. We begin with this bit, yeah, that's the first thing that's happening. So you start with x, you add 2 to it. So if we think about the transformations, f of x goes to f of x plus 2. This time, the change is inside the bracket. So we're going to be moving the points sideways. Move sideways, it's next to the x. So we're going to get a translation because we're adding stuff. And this does the opposite to what you expect. So sideways, -2, 0. So my graph, again, has the same shape. But this point has moved -2. And now my lowest point must be at -2 and on the axes because it's moved back 2. And my x-coordinate again here, my x-coordinate must have gone down 2, so that must be at 4, 4 now. 4, 4. And now we've got to add 2 to it. So we've got f of x plus 2 plus 2. And this is now outside the function. It's not in the bracket. Yeah, it's not in the bracket next to the x. It's outside the function. So we have moved the graph in the y direction. Yeah, so this is outside, outside, outside f blah blah blah. Therefore it moves up and down. So we're going to get a translation again because we're adding something. 0, and it's outside, so it does what it expects it to do, so we add the 2. So this graph that we had before is going to move up 2. It's got the same basic shape. If we move this point, the turning point at the bottom here, up 2, that's going to take it onto, whoops, the x-axis. So that's going to be our x-axis, and our y-axis is also going through that point. And then we've got our point 4, and it's been moved up 2, so that's 6. And it also asks where the origin will be. Well, the origin has gone back 2 and up 2. So this is what we could call O dash, and that will be at -2, 2. Hope that's clear. And this is at 0, 0. Okay, part C. Come back. Y equals 1/4 f of 2x. Y equals 1/4 f of 2x. We probably should have labelled this line here as well. Y equals f of x plus 2 plus 2. Okay, so again, we're going to start with the bit that's in the bracket, the 2x. So f of x translated to f of 2x. It's multiplying, so we get a stretch. It's inside, yeah? The change is inside the bracket, therefore it's changing x. Move sideways, but it's the opposite of what we expect. So the basic shape stays the same. We're moving it sideways, so the x-axis must be at the same sort of height if we go back to the original one. So one of the turning points below, one above, so it's coming through here. If it's moving that direction, the y-axis is invariant, so that's still going to go through the origin. Now the key points. Scale factor 2, stretch y-axis invariant, scale factor is 1/2. It's the opposite to what you expect when it's inside. So we get 2 minus 1 here. We're going to half the x value, so it's going to go to 1 minus 1. And here we're at 6, 4, so we're going to halve the x value, so we're going to be at 3, 4. Okay, now we've got the next part of this to do. We've got 1/4 of f of 2x. This time the change is outside the f bracket. Yeah? This is, oops. outside f blah blah blah. So it moves in the y direction, therefore moves it up and down. So this is going to be a stretch. Scale factor a quarter in y direction. So we're now ready to do our answer, because that's the last transformation. Oops. Usually best to draw the shape first, so it's not, the basic shape doesn't change. Our x-axis, we've had no translation, so our x-axis and y-axis are staying in the same place. We've got 1 minus 1, and that's going to be stretching a quarter in the y direction. So this will still be at 1 for x, but it will now be negative a quarter for y. This point here, the max, no change in the x direction from here across to here. And then we're going to have a quarter of the y component. So a quarter of 4 is 1. X, y, y equals a quarter f of 2x. Part D. Yeah, the more complicated these are, the more important doing the sort of planning is. So y equals minus f of x minus 1. Y equals f of minus x minus 1. I think I got that right. No, minus f of x minus 1. Y equals minus f of x minus 1. Okay, so if we start with f of x, our original shape, the first change, yeah, if you imagine building it up, the first thing we'd have to do is subtract 1. So that is inside the f bracket, isn't it? Therefore, points move from side to side. So it's going to be a translation, because we're adding stroke subtracting something. And this time it's going to be, it's the opposite to what you expect, so it's 1 to the right. So translation, 1 to the right gives f of x minus 1. So again, we can have our original shape. It's moving sideways, so the x-axis is still going to go in between the max and min points. The difference is it's moved 1 to the right. So if we move it 1 to the right, the y-axis is going to go through somewhere here. Oops, that's not very good. Let's just do that again. I'm also going to move this down a bit so I can get the y-axis in here. So that point is at 1. This point was at 2 minus 3. So that's 2 negative 3. Sorry, I looked at the wrong one then. So it's at 2 minus 1, and we've moved 1 to the right, so it's going to be 3 negative 1. Yeah, because we've added 1 to the x value. Adding 1 to the x value. Here we've got to add 1 to the x value, so it'll be 7, 4. Okay, now it's negative f of x minus 1. So this minus 1 is outside of f brackets, therefore it's going to move it in the y direction. And when we change the sign, it's a reflection. And if the point's going to move up and down, it's got to be in the x-axis. So if we reflect our shape, it's going to now go, if you like, from a negative cubic shape to a positive cubic shape. And we're going to have, this is still going to be 3 across, but it'll be plus 1. This will still be 7 across, but it'll be negative 4. And the origin moved 1 to the right. So this point here is 1, 0, and that is O dash. It's where the origin has gone to.